Good morning. With you today, your math teacher, Mrs. Rabab Ahmed, for covering lesson 1 in unit 4, prep 2 geometry. Our lesson today is the equality of the areas of two parallelograms. Let's move to slide number 2. The equality of areas of two parallelograms. The surface area of two parallelograms with common base and between two parallel straight lines. One of them is carrying the base are equal in area. As we see in the figure, if we have ABCD and the parallelogram EBCF, two parallelograms with common base which is CB, and CB parallel to FA, and one of the two parallel lines carried the common base. The parallelogram and the rectangle also with common base and between two parallel straight lines are equal in area. Look at the second figure here. We have a rectangle which is AEFD and the parallelogram ABCD. The common base here is AD and the two parallel lines here is AD and FB. So we can say that the area of a rectangle equal the area of parallelogram. Let's move to slide number 3. The area of a parallelogram equal the length of base times the corresponding height. Rule D already, we have studied this rule in primary 4 or 5. So I want you to remember the area of a parallelogram equal the length of the base times the corresponding height. The parallelogram with bases equal in length and lying on a straight line, while the opposite side to this base are on another straight line or equal in area. Let's move to slide number 4. Complete. The surface of two parallelograms with common base and between two parallel straight lines. One is carrying this base or equal in area. Number 2. The parallelogram and what with common base and between two parallel straight lines are equal in area, a rectangle. Number 3, the area of parallelogram equal base times corresponding height. Number 4, the area of parallelogram with base equal in length and lying on straight line, while the opposite side to these bases are on the another parallel straight line are equal in area. Let's move to slide number 5. To the correct answer. If the base length of a parallelogram is 7 and the corresponding height here is 4, then its area, as we studied before, area equal base times height, so 7 by 4 equal 28 centimeters squared. So the right answer here is letter D. Number 2, if the area of parallelogram is 35 and the height here is 5, then the length of the corresponding base is 35 divided 5 to calculate the base equal 7 centimeter. So the right answer here will be letter B. Number 3, the area of parallelogram is 50 centimeter square and the base length is 10. Then the corresponding height to the base equal, to get the length of the height, area divided base equal 5 centimeter. So the right answer here will be letter B. Let's move to slide number 6 here. If the length of two adjacent sides of a parallelogram 8 and 10, imagine we have a parallelogram, two sides here 8 and 10, so the greater height here is 5, then its area equal 8 by 5 equal 40 centimeter square. Number 5, if ABCD is a parallelogram in which AB equal 5, BC equal 10 and its smaller height is 4 centimeter, then the greater height here is what? At the beginning we will calculate the area of a parallelogram. 4 by 10 equal 40. Then to get the greater height here, divide 40 divided 5 equal 8 centimeter. Number 6, a parallelogram whose area is 50 centimeter square and the length of its base equal twice the corresponding height, then the height equals what? Let the height here is x and the base is 2x. Then the area of parallelogram equal base times height. So 2x times x equal 50. 2x squared equal 50. x squared equal 50 divided 2 equal 25. By taking the square root of 25, x equal 5 centimeters, so the height here is 5 centimeter. Let's move to slide number 7. In the opposite figure, AB parallel to DE, x and y belongs to straight line AB, XDEY is a rectangle, and AD parallel to BE. At the beginning, find the area of the figure ABED. If AD equals 30 centimeter, find the length of the perpendicular from B to AD. As we see, AB parallel to DE and AD parallel to BE. So ABED is a parallelogram. X and Y belongs to straight line AB. So we can say that AE parallel to AD. In the rectangle XDEY and the parallelogram ABED, ED is a common base. So AY and AY parallel to ED, here we have the two conditions, common base and two parallel lines. The area of rectangle equal the area of a parallelogram. So we can say that 12 times 24 equal to 188 centimeter square. So the length of the perpendicular from B to AD equal to 188 divided 30 equal 9.6. Let's move to slide number 8. In the opposite figure, we have ABCD, the rectangle, AE parallel to DF, E belongs to BC, and F belongs to FB. Prove that the area of the figure ABCM equal the area of the figure DMEF. Prove that. So ABECD is a rectangle. AE parallel to DF, E belongs to BE as we see. So AD parallel to EF. Therefore ADFE also is a parallelogram. In a rectangle ABCD and the parallelogram ADFE, we have AD is a common base, AD parallel to BF. Area of parallelogram equal area of rectangle. By subtracting the area of a triangle AMD from the two sides, we have the area of the figure ABCF equal the area of DMFEF. We have finished, and thank you for your listening.